you felt went well for yesterday. There's still a few of you who need to finish it up. So remember, before after school today, if you try to come right after school, I have a meeting. Well, all teachers have meetings, so we'll be available probably closer to around 3:20 if you want to do it today after school. Other than that, let's talk about the bell ringer. So the bell ringer itself, what do we do to solve this? What's our process for solving this, Brooke? Goodness. Yeah, I do. What's our process for solving these?
I'll put 24 in for x. Right?
Put 24 in for x? Well, then we wouldn't need the value of x, right?
Oh.
What's our process, Foley?
You plug in the 24 for the h of x, and then you solve it like you would solve.
Plug the 24. So we've got two things that h of x is equal to, right? So we talked about when we have two things that h of x is equal to, we set them equal to each other. Because really what we're plugging in for h of x is both of those things, and we're setting them equal to each other, because h of x is always going to be equal to h of x. So we had a problem like that on the quiz. So in order to do that, we would go in and we would say 3x equals 24. And then how would I solve that, Cadence?
You would divide by 3.
Good. Divide by 3, divide by 3. When I do that, what do I come up with? X equals 8. So that would be the correct way, all right? So that should be a review. Hopefully you remembered that on the quiz yesterday. Right? Let's move on to today's section. We're going to start talking more and more about graphing in this section. Right? And we're going to talk specifically about graphing linear equations and standard form. What are linear equation graphs going to look like, Nick? Yeah, straight lines. So that's really important to remember. If you ever tell you that you're graphing a linear function or a linear equation, you already know that the graph is going to look like a line. So we know we're going to be graphing lines. We're going to talk about a couple of things with it. Oops, I'm sorry about that. Levi, did you take solace in knowing or watching the Astros lose last night?
Yes. I want to
What? They got that big controversy going on right now too. Yes, Cadence? What a good friend. What a good friend. Alright, everyone got a copy of the notes? Alright. So let's talk about this. So today's 3.4, graphing linear equations in standard form. I didn't give you guys one. Too busy talking smack about the Yankees, wasn't I? Sorry. Whoa, whoa. Aren't you like a Reds fan or something? Yeah, isn't you like the Cincinnati Reds?
No.
Oh, Red Sox, sorry. They didn't even make the playoffs. So. Alright, so, sorry, everyone have notes now? Yes? Okay. Alright, so we're talking about graphing linear equations in standard form, and that standard form is key, alright? Because this isn't our y equals mx plus b that we've been kind of talking about, it's a different form of that. So our learning objectives today is learn how to graph equations of horizontal and vertical lines. These look a little bit different. All right, the equations of horizontal and vertical lines, they look a little different. We're going to learn how to graph linear equations in standard form using intercepts. So we're talking about x and y intercepts. And then we're going to talk about using linear equations in standard form to solve some real life problems. So how can you figure certain things out through linear equations. So let's talk about the words you need to know. First one, standard form. All right, standard form. This is an equation that looks like this. ax plus by equals c. So when they're talking about standard form, they're putting the x's and the y's on the same side, right? the big thing with those A, B, and C is that you have to know is that A, B, and C are real numbers. Real numbers. So we're just substituting at this moment A, B, and C, all right? But they're actually real numbers. And what are real numbers, Caden? Do you recall from algebra prep what you learned about real numbers?
Anything that can make a statement true.
Kinda. You can make a statement true. Do you remember anything, Levi? No. So real numbers are numbers that can be both positive or negative. Right? So when they're saying A, B, and C are real numbers, it could be a positive number or a negative number. Right? So it could also be a decimal, it could be a fraction. Right? All those things are possibilities. They're going to be positive or negative. Right? And then the last part is A and B are not both 0. They can't both be 0. Now one of them could be 0. We could say 0x plus 5y equals c, whatever c is, right? Whatever number or fraction or decimal, whatever it is, right? But A and B can't both be 0. Then this would be completely untrue. It wouldn't be possible, right? So A could be 0 and B could be a number, or B could be 0 and A could be a number, but they just can't both be 0 at the same time. So let's talk about x-intercept. D, what do you remember about x-intercepts? What is that? X-coordinate where? Remember anything about where the x-coordinate? What do you think, Foley? Can you add on to that?
The x-intercept is where your line crosses your x-axis.
Very good. So it's the x-coordinate where it crosses the x-axis. So when we're talking about x-intercepts, we're talking about where the graph crosses the x-axis, and that's going to be a specific x-coordinate. Now, anytime we have an x-intercept, we're talking about where it crosses the x-axis. The big thing you got to remember is y is always going to be 0. So your order of pairs is going to look something like that. It's going to be x, whatever that number may be. It could be -2, -5, +3, whatever it is. And then the second coordinate, the y coordinate, is always going to be 0 for an x-intercept. So x is going to be the number, the y coordinate will always be 0 on an x-intercept. Now using that logic, Charlie, what's the y-intercept? No. Using that information we just learned about x-intercept being where the graph crosses the x-axis, what do you think the y-intercept is?
0, 1.
Yeah, that would be correct. That would be the order of pairs. So how do we say that in words, Jamie?
Where the graph crosses
The x-axis?
I mean, y.
The y-axis. So, as Jamie told us, that's where the graph crosses the y-axis. And as Shiloh told us, the order of pair would look like this. 0, y. So, we're always going to have a 0 for the x-coordinate in our y-intercept. And then y is going to be whatever that number is. So, when we're talking about x-intercepts, we're talking about where it crosses the x-axis on the graph. Y-intercept, we're talking about where it crosses the y-axis. Oh man, shoulders getting sore. I got one of those flu shots this morning.
You have to get those?
You don't have to, it's just a good idea. It's supposed to be an extremely bad flu season. Sorry, I digress. Let's talk about graphing horizontal and vertical lines. Horizontal and vertical lines. So horizontal lines, here's what we need to know about horizontal lines. They always look like y equals b. Right? They always look like y equals b, and b is just some number. So we're just putting it in. So we could say y equals 6, or y equals -5. Right? If it's a horizontal line, it's always going to look that way. It's always going to be y equals and just a number. There's not going to be an x involved. Right? There's not going to be any other thing going on. It's just going to be y equals some number. We're going to call that number b. Well, that same idea is true for vertical lines, right? Except for, instead of looking like y equals some number, it's now going to be x equals some number, and I'm going to call that number a, all right? So x equals some number. So you're going to know it's a vertical line if all you have for your equation, right, is x equals a number. So if I x equals 6, that's a vertical line. You know it right off the bat. That's why it can't fall into that standard form, or not standard form, that slope-intercept form of y equals mx plus b. Right? It looks a little bit different. So with vertical lines, you just got to remember that x is going to be a number, or it's going to say x equals some number. For horizontal lines, they're going to say y equals some number. Horizontal lines have no x's in the equation. Vertical lines have no y's in the equation. So that's going to be our cue into what it looks like. All right? So let's talk about a couple. So we've got, let's do this first one. Y equals 4. What kind of line is that going to be, Austin? What's it going to look like? You think it's vertical? What's your note say? What do vertical lines equations look like? Going to be horizontal, right? And so the thing we know about this is it's going to cross the y-axis at exactly 4. Right? Because y equals 4. So it's going to cross the y-axis at 4. So in order to graph this, first thing I have to do, what's the first thing you have to do, CC, before you can even graph a line? Yeah, we're going to label the graph. So I'm going to label my graph 1, 2, 3, 4. I'm just going to keep it small. I'm not going to label every single part. But I'm going to make it obvious what I'm counting by. I'm going to do the same for my negatives. Plus you, Wayne. So nice and easy to see. Alright? Now, which one of these axes, Sierra, is the x-axis? Going like that? Yeah. What direction is that? Left and right. So that's going to be our x-axis, which means the other one is our y-axis. So just a reminder of that. So we're talking about horizontal line crosses the y-axis at 4, because y equals 4. So I'm just going to create a spot on the y-axis, a point right here at 4. And then through that, I know that this line looks like what again, Austin? What kind of line? Horizontal. So all I've got to do, take my ruler and draw a horizontal line that goes across 4, and that is terribly not straight. Make sure you use your ruler on your assignment for your notes, not that big of a deal, but on your assignment, make sure you use a ruler. But we've got a nice straight line going straight across horizontally, right? That's the idea. Right, so that's how that one looks. You guys do the second one, check in your group, see if your graphs look the same. And if you prefer to have a nice straight one, you can borrow, of course, one of the rulers over there for your notes, but also for your assignments. Make sure you're labeling those graphs, that's important. So this second one, Vince, what's this line going to look like for y equals -3? What kind of line is it going to be?
Horizontal.
Horizontal, we know that. All right. Where is it going to cross the y-axis, Ava? -3. So if I label my line, I'm just going to do it really quickly. -1, -2, -3. Right? It's going to cross the y-axis, which is the, Destiny, which axis is that? The left or right or the up and down?
The up and down.
The up and down one, right? So that's what we're talking about. It's going to cross at -3. So then I can go in and create my line going horizontally, as you guys just told me, and make it as straight as possible. Now, one thing I want to make sure you understand when you're graphing your line, right, is that it needs to extend all the way across your graph, right? Because lines extend all the way across the graph. So that's really important because they go on forever, as well as we need to have arrows at each end of our line because they go on forever in both directions. So make sure it's going to become more and more important, especially like on our last problem today, that we don't just stop it and make it 2 squares wide. It goes all the way across. Let's put that away for right now. Let's make sure we're staying engaged with this. So we need to make sure all the way across our graph. All right, give me a thumb sign where you're at with the horizontal lines. Yeah, pretty easy? Okay, good. So let's move on and talk a little bit more about the vertical lines. Okay. Now, vertical lines, what do their equations look like, Brooke, for vertical lines?
The vertical x-axis.
I know, what's the equation look like?
X is the
X equals some number, and we'll call that number A. So this first one, we've got x equals -2. So Lane, where is that going to cross the x-axis? At -2. And which axis, Tanner, is the x-axis? Yep, left to right. So we got to remember that it's going to be crossing at that spot of -2, as Lane just said, on the axis that goes left to right. So we need to again label our graph. So I'm just going to label a couple quick numbers so it makes it obvious what we're counting by. So I just counting by ones, making it nice and easy. And Lane says it's going to cross the x-axis, which Tanner said is the left and right axis at -2. So I'm going to create my dots at -2, my point, and then I'm going to take my ruler and I'm going to draw a nice straight line that extends all the way through the graph. Again, on your notes, if it's not perfectly straight because you're not using a ruler, it's not that big a deal. On your assignment, it's going to be a big deal. So make sure you're using your rulers, right? A nice vertical. So that's what we're going to look like. You guys do the second one. We'll check it here in a second. Make sure your graph matches up with your partners at your group. All right, Kieran, so where is it going to cross? At what axis and at what point?
It's going to cross on the x-axis
At
at 5.
5. And D, which one's the x-axis? Up or down or left or right?
Horizontal.
Yep, the horizontal. Good word usage right there. So, label my graph real quickly. 2, 3, 4, 5. It crosses at that point 5. And I create a nice straight line that goes right through it. So, boom. And then make sure arrows at each end. That signifies it's a line and not a line segment. Right? Again, because it extends on forever. How do we feel, Cadence, about the vertical lines? Good? Do we concur with them? Does everyone feel good about the vertical lines? Yes? No? Maybe? What do you think? Yes, Brooke? Alright. Brooke feels good, I feel good. Alright? So let's move on. X and Y intercepts. Let's talk about this. So this is really just a two-step process to find your x-intercept, and then it'd be the same thing to find your y-intercept. So we're talking about when we're in standard form, which is that ax plus by equals c. Right? How to find the x-intercept? First, substitute 0 for y. So you plug in 0 for y, and then second step, solve the equation for x. So plug in 0 for y, solve the equation for x. Now it's super tricky, Levi, how you do it for a y-intercept, so make sure you're paying attention, alright? So when we do the y-intercept, we substitute 0 now for x, and then we solve for y. So it's not really any different. It's the same process as you did for the x-intercept. With the exception of, instead of substituting 0 for y, you're now substituting it for x, and then you're solving for the remaining variable. So whichever one you're trying to solve for, if you're trying to solve for the x-intercept, you're going to plug 0 in for y and solve for the remaining variable. If you're trying to solve for the y-intercept, you're going to substitute in for the other variable, which is x. You're going to put a 0 in that spot, and you're going to solve the equation for y. All right, so let's do a couple. First one, find the x and y intercepts and graph. Right? So we've got 3x plus 4y equals 12. 3x plus 4y equals 12. So let's start with the x-intercept. Right? My first thing I'm going to find is the x-intercept. So I've got an x-intercept right here that I'm going to find. I'm just going to label it so I know what I'm doing. All right. And in order to find the x-intercept, I need to plug 0 in for what, Vince?
Y.
Y. So the 3x, that's going to stay the same. And I'm going to plug 0 in for any y's I see. So I have plus 4, there's a y. So I'm going to plug 0 in, times 0 equals 12. Now anytime you plug anything, or you plug a 0 in and it's multiplying something, what happens with that? Turns into 0. So really it just cancels and goes away. So this cancels, and I'm left with 3x equals 12. So 3x plus 0 is still 3x. And then how do I solve from there, Destiny?
You divide.
Divide by,
Or
on where?
the x interval.
On both sides. Divide by 3, divide by 3. I'm left with x equals what, Kieran? X equals 4. Right? So there's our x-intercept, but we have to write that in an ordered pair. And Shiloh, what does the x-intercept ordered pair look like? So if I was going to write those in those two coordinates, the x and y coordinates, what would it look like? 4, 0. Perfect. 4, 0. So there's my x-intercept. Right? I've got that right there. Now I've got to go in and I've got to find my y-intercept. So when I go in to find my y-intercept, how do I find that, Grosnick? Substitute 0 in for x. Very good. So I got 3 times, there's my x, 0 plus 4y equals 12. Well, as you told me, anything times 0 is 0, and 0 plus anything is just itself. So those really just cancel, and I'm left with 4y equals 12. And how do I solve that, Austin?
Divide by 4 on each side.
Good. Divide by 4. Divide by 4. When I do that, y equals what? 3. How do I write my ordered pair for the y-intercepts here? 0, 3. Boom. So I got my two ordered pairs. I've got 4, 0, and 0, 3. 4, 0, and 0, 3. So now I need to graph my line and see what it looks like. So first thing I have to do, Levi, in order to graph is do what? Label it. So I'm going to go in and label it. I'm going to count by ones. I'm just going to label it to 4, and that'll be good enough. Everyone can tell what I'm counting by then. So I'm labeling it by 4, or by 1, excuse me. Nice and labeled. Good to go. Then I need to put my x-intercept on there, which was 4, 0. So I go right 4, and then stay on that, and that's my x-intercept right there. So there's my first one. Then I need to go to my y-intercept, which is 0, 3. So I'm going to stay where I'm at, and then I'm going to rise 3. So there's my 2 points. To complete the line, I need to take a ruler, and I need to connect the dots and extend that line all the way through the graph. So as best I can, oh, that was terrible. Missed that one completely. All the way through the middle of those lines, right? So we need to do our best that we can to get all the way through the middle. I'm going to use up here because I just can't get it on that iPad. So I'm using my ruler right through the middle of both lines, extend it as far as we can through the graph. Your ruler will cover your whole graph. This one doesn't. But that's the idea. And it's going to be really important, again, extending all the way through, because we're going to need that data in certain situations of where it exactly is crossing. All right, second one's on there. You guys try it, solve your x and y intercepts, and graph it, and then we'll talk about it here in a minute. So, this does not work here. You have an order pair here, an order pair here, and you just go back. And you make a line segment. And lines extend all the way, and they have arrows at both ends. So make sure. So a negative times a positive is a positive. So really this is like a negative 1y. We'll have, if it was in here, if it was negative 2, what would you do to get rid of it? Negative 2y, because what's the negative 2 given to the y? Yeah, so we're just really going to divide by negative 1, so that'll get rid of. Alright, let's talk about this one because it is a little bit tricky at times, right? Especially when we get down to that y-intercept. And this was a common occurrence on one of our quizzes that I saw when we got there. So what is our x-intercept for this problem, Foley? What'd you come up with? Oops. What'd you come up with for your x-intercept for the problem?
2, 0.
2, 0, she says. Right? Do you agree with that, Sierra? Did you come up with 2, 0 for the x-intercept?
Yeah.
Yeah? What do you think? Grusnik, 2, 0? Yeah? I think we're all in agreement on the 2, 0. Yes, ma'am.
Can I talk, is Lane here?
Yeah, he's
Talk
right
to him
there.
real quick. For
Yeah.
your book.
Yeah. Alright, so let's talk about the y-intercept though. Tanner, what'd you come up with for the y-intercept on this one? 0, 4, he says. What'd you come up with, Jamie? 0, negative 4. Alright, so I saw that consistently. So it's either positive or negative 4. We'll figure out which one it is. So let's solve it. How do we find the y-intercept? What do you think, Dee? How do we find the y-intercept? How do you solve for it? We don't know what it is. We got to find it. That's what I'm asking. How do you find it?
Well, I mean, substitute x for 0.
Yeah, very good. We substitute 0 in for x. So let's do that. So I've got 2 times 0 minus y equals 4. Now anything times 0 is 0. So what really happens with this? Cancels, right? But then I'm left with negative y equals 4. Some of us just said, oh, y equals 4. Can't get rid of our negative there. It stays there. So when we have negative y equals 4, how do we get rid of the negative, Levi? Divide by it. Because if this were, let's just say instead of negative y, for some reason was negative 2y. What would you do to get rid of the negative 2? Divide by negative 2, right? Well, there's not a negative 2, it's just a negative. Well, it's really the same as negative 1y. So we divide by negative 1, divide by negative 1. Those cancel, and 4 divided by negative 1 is negative 4. So our our y-intercept is 0, negative 4. So don't forget, the negative doesn't drop off just because this canceled out. Right? We still have to work the process to get rid of the negative, which would be divide by negative 1. Alright, so we've got our x-intercept and our y-intercept. So I would graph those. So first thing, label our graph. And it looked like we did a pretty good job on the whole of labeling them where they were easy to see. And then I graph my 2 points. So first one, 2, 0. Second one, 0, negative 4. Then I take my ruler, connect it through the middle of the dots as best possible, and then graph, extend my line as far as I can. On yours, you should be able to get all the way through it. Right? And what has to go at each end of these? Arrows, because it's a line and it goes on forever in both directions. Right, give me a thumb sign where you're at in finding x and y intercepts and then using those to graph. Good? Alright, it looks like we're in pretty good shape. Just don't forget about if you end up with a negative y, we have to get rid of that negative. Alright, let's talk about our last one. So a real life problem. Yeah! This one would be really applicable for females as you're planning your weddings at some point. Alright, so here we go. You are planning an awards banquet or a wedding in your future, alright, for your school. You need to rent tables, because you're going to have a reception, right? It's a party, it's a celebration, alright? So you need to rent tables to seat 180 total people. Tables come in 2 sizes. Small tables seat 6 people, and large tables seat 10 people. The equation for 6x plus 10y equals 180 models this situation, where x is the number of small tables and y is the number of large tables. Right? Because when you're planning those weddings, sometimes one side of the family can't sit with the other, and you got to separate them out, so we can't always use large tables. We got to have smalls, and it gets complicated, right? So we've got to figure out what are the options with this. Well, in order to find, all right, this, we need to find the intercepts. Where does it cross the x and y axis? So you guys know how to find the intercepts, right? And then once we've done that, we're going to figure out 4 possible solutions for the context of this problem. So, because there's more than one solution on the amount of tables we could utilize. So first thing we're going to do is we're going to solve for the x and y intercepts. You guys know how to do that, right? So let's do that. Let's find the x and y intercepts of this problem. So where does it cross the x-axis? Where does it cross the y?
Great that you can already figure this out, because we're going to be looking into that. So it's not really what we're working on at this moment, but it's good that you already know that.
Okay. All right, Lane, what'd you come up with for the x-intercept on this?
X equals 30.
Says x equals 30. Do we agree with that, Cadence? Yeah, for x-intercept. And how do we write that, Lane, as a ordered pair?
30, x.
30 comma x?
0.
0, there we go. All right, what about our y-intercept? Sierra, what'd you come up with for that? Y equals 18, and how do we write that, CC, as a ordered pair? Comma 18. Good. Does anyone disagree with those x and y intercepts? It looked like from what I saw, most everyone was getting those for the x and y intercepts, so that's great. And I want to apologize, I got the wrong graph on yours. Like, you could use the graph that I gave you, but I really want a segmented graph, and so I apologize. If you want to transform that, that's fine. But just for the sake of being able to see better, I'm going to use a segmented graph. So this is my y-axis right here in the positive area, right? And then this is going to be my x-axis in the positive area, right? So we're working in what's called quadrant 1. That'd be that upper right corner, right? Because you can never have a negative amount of tables, right? I couldn't have a negative large table. I couldn't have a negative small table. It's only positive numbers that we're working with. So really all we're working with is this area of the graph. Right? And I want to make sure it's really clear because this will make it easier for us to see what the possible combinations are. Right? So we agree that these are our x and y intercepts, so I'm just going to label my graphs, or label this, so I'm just going to count my 2's. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, oh, that's good, and then I do the same over here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30, alright? So the reason I want to use this graph in this form is just to show you those combinations. So first one, my x-intercept is at 30, 0. So my first point is right here at this spot. So 30, 0. Boom. Second one, 0, 18. So I'm going to go up and create my y-intercept, which is right here at this point. Right? Then I need to connect those dots as best possible. I don't have a great super long ruler. If any of y'all are looking for an early Christmas gift, I could use a giant ruler. All right? In case you're looking, you're like, oh, I really want to get him an early Christmas gift. Please feel free to get a giant ruler for me. All right? So I'm going to do my best to connect these straight all the way through with this tiny ruler. But our goal is to get right through the middle of those dots as best humanly possible. So there we go. Alright, there we go. So it extends all the way through. Yours is a little bit smaller, so it might be easier to see. So the x-intercept and y-intercept, are those possible combinations of tables we could use? They are, right? It says that the x is the small tables, right? So if I had 30 small tables that sat 6 apiece, would that meet 180 people? Yeah. So there's my first combination. What about y-intercept? If I had 18 large tables that sat 10 people, would that be 180 people? It would. So these are 2 possible combinations. So we've got to figure out 2 more. Well, if we've got a really well-drawn graph, we can look at it, all right, and see where it crosses possible spots. All right, so one of the spots that I see that it crosses, all right, evenly at a spot is right here, all right, at when x is 20 and y is 6. Well, let's see if that math works. All right, 20 times x, which is the 6, that'd be 120, and then 6 the tables that see 10, that would be 60, and 120 plus 60, 180? Yes, it is. For whoever said no. It is, all right? So it's 180. So when we graph those, we can see those exact spots that it goes through. And that's why I apologize that your graph is not the correct one, all right? Because this would make it a lot easier. What's another possible combination, Foley, that could be?
10 small tables and 12 large tables.
Yeah, so 10 small tables. If I look, my small table's right here. And look, right there, go across, 12 large tables. So it crossed right through that spot that it was supposed to. So if we're accurate with our graphs, all right, we ended up with a point here, and we ended up with a point right here. All right? And so that line connected straight through those. So 4 possible solutions, and there might be others, right? But 4 possible solutions are... Four possible, I can spell, solutions. Give me the first one that we figured out, Jamie. 30, what kind of tables? What kind of tables were they? 30, 0, but was it 30 large or small tables, or what were they? 30 small with 0 large. All right. What's another combination lane that we figured out? 10 and 12. So 10, what kind?
10 small tables.
10 small and 12 large. Good. Third combination we figured out, D?
0 small and 18 large.
0 small, 18 large. And last combination we figured out, Grosnick? 20 small and 6 large. So again, if you've got a good graph and you do a great job with your line, you're just going to simply be able to look at it and go, oh, that passes through that point, that crosses through that point. Those are obvious choices for us. So these would be 4 possible solutions. Then the last thing you have to do is you've got to look at your family and say, who can't sit with who and how many people can I put at which table because they're going to fight and I don't want that at my wedding. All right? So that's the big thing. All right? These are possible solutions. All right? Can't fix your family, but you can fix your seating arrangement. All right? How do we feel about using the x and y intercepts to figure out things like this? Give me a thumb sign. Good? All right. Well, your assignment's listed there at the bottom. You can get a jump start on it. I'll put the exit ticket up here in a little bit when the bell's going to ring, which is still a little ways away. You got some time to work on your assignment.
Can you just go there and give me to him?
Okay, you just want to run those up. Thank you. You bet.